Today we're going to graph quadratic functions and talk about vertex form. Let's start with the parent function y equals x squared. This is the most basic form of a quadratic, and it's a quadratic because it has a 2 for the greatest exponent on a variable. In order to graph it, I can plug in different values for x and make a table of values. When I plug in -3 times itself is 9, -2 times itself is 4, and so on. Then I can plot these points and see what shape they make. When I connect the points, I get the shape of a parabola. That's the shape you'll get when you graph quadratic equations. Notice this here is the vertex. The vertex is the turning point where it changes directions. It's either your minimum or your maximum. The vertex of the parent function is located at 0, 0. Now let's change the parent function and see what happens. Let's graph y equals x squared plus 3. Let's plug in these x's to make a table of values. Now I can see I still have a parabola, but it has shifted up 3 units. The vertex is now located at 0, 3. What do you think will happen when I graph y equals x squared minus 3? Let's make a table of values and find out. This time the parabola shifted down 3 units. That minus 3 caused the vertex to move to 0, -3. I've redrawn the parent function. Now I'm going to test out what happens when I add 3 before I square it. Let's make a table of values and graph the points. -3 plus 3 is 0, 0 squared is 0, -2 plus 3 is 1, 1 squared is 1, and we'll keep going here. Some of these points won't fit on my graph, but I can see here this pink line is starting to form a parabola, which it should. So let's plug in some more values to see what happens over here. Let's plug in -4. -4 plus 3 is -1. -1 times itself is 1. -5 plus 3 is -2. -2 times itself is 4. And now I can see this parabola is forming. I also know that parabolas are symmetrical, so any point I have on this side of the parabola, I can reflect it and find it over here. Notice how adding 3 inside the parentheses moved my parabola 3 units to the left. That might be opposite what you were expecting, but here's my vertex at -3, 0. Now let's make a table of values for y equals x minus 3, all in parentheses, squared, and see how that changes the parabola. So once I graphed these points, I can see that the parabola moved 3 units to the right. I subtracted 3 inside the parentheses, and it shifted the vertex over to 3, 0. If you're wanting to identify the vertex just looking at the table of values, look for when you change directions. So here the y's are decreasing, and then they start increasing. So that's my vertex. It's the turning point. Let's see what happens to the parent function when there's a negative in the front. That's kind of like a -1 coefficient. So here's my parent function. Now let's make a table of values for y equals -x squared. -2 times itself is 4, and then that negative will make it negative. So you can see that negative in the front reflects the parabola over the x-axis. Let's see what happens when our coefficient is a number like 2. -2 times itself is 4 times 2 is 8. -1 times itself is 1 times 2. Here's the parent function. Let's see how this is a little bit different. So the vertex stayed the same, but that coefficient made this graph get skinnier. It squished it toward the y-axis. Anytime you have a coefficient greater than 1, your graph will get skinnier. So what do you think will happen when we have a coefficient less than 1? Let's plug in these numbers and find out. It made the graph wider. So anytime you have a coefficient less than 1, you can expect that parabola to get wider. Let's look back over all these changes and transformations to the parent function to see where vertex form comes from. When you have a constant, that shifts the parabola and the vertex up or down. If you add, you move up. If you subtract, you move down. If you have a number inside the parentheses adding or subtracting with x, that's going to shift it left and right. If you add inside the parentheses, you shift left. If you subtract inside the parentheses, you move right. A negative in front for a coefficient flips the parabola upside down to open down. A coefficient greater than 1 makes the graph narrower. A coefficient less than 1 makes the graph wider. So now we can see here, this is vertex form, and each of these pieces affects the parent function. Let's talk about what each letter does to the graph. If A is positive, your graph will open up. If it's negative, it'll open down. If A is greater than 1, you'll have a narrower parabola than the parent. If it's less than 1, it'll be wider. This number inside the parentheses tells us to move left or right, and this number outside the parentheses, or the constant, tells you to move up or down. If we know these two numbers, we can identify our vertex. Our vertex is located at HK. Remember to watch out for this sign here. You can see it's negative in the formula for vertex form, a minus, because a minus moves you in the positive direction. Let's look at this example and think about how this graph is different than the parent function. The 3 here is positive, so it's going to still open up, but it's greater than 1, so we're going to have a narrow parabola. We're subtracting 4 in here, so remember subtraction moves the graph in the positive direction if it's inside parentheses. So we're going to move to the right 4. And then subtracting 8 here will move the graph down 8. That means our vertex will be located at 4, -8. Let's look at this one. Notice we have a negative. That means our parabola will open down. There's a 2 out here, so that's going to make the parabola a little bit narrower than the parent function. This 13 in here is being added, so we'll move left 13. 18 is being added outside the parentheses, so we'll move up 18. If we wanted to know the vertex, since we understand vertex form, we can just look for the location of h and k. Remember, h has to switch the sign, so we have a negative 13 and a positive 18. What if you want to find the zeros or the places where this parabola would cross the x-axis? Those are called the zeros. If we wanted to find those, we could plug in a 0 for y. Be sure you take note here. When you take a square root, don't forget that you have a positive and a negative 3. So when I solve this, I need 2 solutions. Negative 10 and negative 16. So if I were to graph this parabola, I could put the vertex at negative 13, 18, and my 2 zeros, or my x-intercepts, would be at negative 10, negative 16. One way to check your work is to be sure that these are the same distance from your vertex. And they are. To sketch or just get an idea of this parabola, I put my vertex at negative 13, 18, and my 2 zeros are at negative 16 and negative 10. My parabola opens down, and it's a little bit narrower than the parent.